everyone, Ismail is here. Today we're going to start the lesson 1.7, the last lesson in chapter 1, inverse relations and functions. You can find this lesson in the pre-calculus student for grade 11 maybe. Okay, now let's start and see what we're going to learn today. We have two things that we need to learn. First, use the graph of a function to determine the inverse, if they have inverse. Okay, then the second one, find the inverse algebraically and graphically. Okay, now you remember that we know that we have two types of function, one-to-one, and we have many-to-one. Okay, but we are not going to look to the many-to-one. We are just focusing on one-to-one. Okay, now let's start with the first part here. First thing, the basic thing about the function. Okay, and the inverse, you know that if you have any function, okay, example, if you have function 2, 5, okay, 6, 3, 1 and 2, okay, so you have this function here, this group of function. Okay, what is the inverse of this function? So let's say all of these are f of x, which is just any random function. Now what is the inverse for this function? So the inverse of this function, from its name, inverse means you just switch between the numbers. Means if you have here 2, 5, so it will become, sorry, let me write here, so the 2, 5, so now look to the first point, so it will be 5 and 2. 6, 3, it will be 3 and 6. 1 and 2, it will be 2 and 1. So this one here is considered as inverse of function. Okay, and what's the difference between function and inverse of function? It's only to the power of -1. So as you can see, the f of x is this one called function. Okay, now what is the inverse of the function? We just write f of to the power of 1, so we call this one inverse function. Okay, so this is the function and the inverse of function in general. Okay, so like if you look here to the first table A and table B. Okay, so table A, let's say we have the tickets here and the cost for each ticket. So one ticket, it costs you $2. 2 tickets cost you 4, 3 it costs you 6, 4 it costs you 8, 6 it costs you $10 for every ticket. Okay, now this is the function f of x. Now to find the inverse of the function, we are going to do the same what we did here. We just switch between the numbers. This 2 should be here and 1 should be here. So we just switch between the numbers. So it will be 2, 1 and 4, 2, 6 and 3, 8 and 4, and 8 and 4, you have to switch between them. Okay, so this is the function here, and this one is f to the power of 1 x. So this one is inverse function. Okay, now I just explained to you what's written here, so we're not going to read this one. Now let's go here to the first and important part to the function, how we can know this function has inverse, because not all functions in math has inverse. Okay, example, let's say f of x with, let's say, mx plus b. This is the linear function, right? So the linear function, it has inverse of function. Okay, but if I said fx, let's say x square, and if I ask you to find the inverse of x square, so the inverse of x square does not exist. So there is no inverse for inverse of x. So how do I know this one has inverse and this one doesn't have inverse? How do I know this? Okay, we have something, we call it here, okay, horizontal line test. What is exactly horizontal line test? From its name, horizontal line, what's the meaning of horizontal line? It's line like this. Okay, so what you have to do, you just draw horizontal line like this one on the graph, and if the graph intersects with your horizontal line with more than 2 points and more, okay, so that's mean this function does not have inverse. Okay, if the function just intersect with only 1 point, so that's mean it has inverse. If the function intersect with 2 points, it doesn't have inverse. Okay, look to this example here. Okay, so the example in this graph, it goes like this, right? Now what you have to do, apply the horizontal line test. So how you can apply the horizontal line test? You know that you use your pencil or the pen that you have. So just put this pencil here like this one, and move your pencil. Just do it like this, just do it like this, do it like this. So every time you're moving your pencil from down to up, you see that the line just intersect only one time. It just intersect one time. Every time it's intersect only with one time with the function. So this function here has inverse. You can find inverse. Okay, look to this function here on this side. Okay, look to the blue one here. So as you can see, just look to the blue, ignore the red one and the green one. So this one is the function. How do I know if this one has inverse or not? So now do the same thing. Take your pencil, okay, and put it here like this, and move your pencil up. So as you can see, more than you moving up, look to the function, it's intersect with 2 points. So this one intersects here and intersects here. This line here intersects here and intersects here. So every time you're moving with the pencil, the function is intersect, the line is intersect twice. So that's mean this one doesn't have, there is no, okay, no inverse. Okay, no inverse. Okay, now this is, I think you can understand the concept of the inverse. Okay, let's take this example to see how we can apply the horizontal line test. First, as you can see, graph each function using graphing calculator and apply horizontal line test to determine whether its inverse function exists. Right, yes or no. Okay, I will not bother you to using graphing calculator to graph it. I'm not going to use it. So I will ask you just to graph the function depend on what we learned in 1.5 parent function. So you know that this is absolute value function. The absolute value function, it's v letter, and when we need to graph it, we start from h and k. And here, as you can see, we have h is 1. Do I have k? I don't have k, so k is 0. So when you need to start the graphing, you plot the points on 0 and 1 and 0. Okay, then you look to the a here is equal what? 1 over 1. So one step up, one step to the right, one step to the left. Then you can graph the function as you can see in the red color here. Okay, now what you have to do to see that, now the question it's asking you, determine is this function has inverse. Okay, now to know, we need to apply, okay, we need to do the horizontal, okay, line test. So what's the horizontal line test? Take your pencil, move your pencil from down to up on the graph. Okay, so now as you can see, let's see. Okay, so it's intersect with 2 points. If I move more, it's intersect with 2 points every time. So as you can see, if only one line intersect with 2 points, so khalas, you don't have to do anything else. So just say no inverse. Okay, let me write here again, no inverse. There is no inverse. Okay, now look to this graph here. Let's graph this function. So as you can see, this is a quadratic function. You know that the quadratic, I will not draw everything here. Okay, I will just draw. Let's graph the function, and as you can see, the highest power represent the type of function. The highest power here is a 3. So this one is a cubic. Do you remember how we can graph the cubic function? You know that the cubic function, it's like something dancing, means the left side is going down and the right side is going up. So the graph is like this. Okay, we're not going to exactly, we just do small sketching. Now let's apply the horizontal line. Okay, test. So the horizontal line, see, it's intersect with 1 point. If I go more, 1 point, more 1 point, more 1 point, every time it should be only 1 point. So as you can see, every time when I apply the horizontal line test, is intersect with 1 point. So this function, yes, okay, it has, okay, we can say it has inverse. Okay, so we are going to know later how we can find the inverse of the function, but now we need just to use the horizontal line test to check that this function has inverse or not. Okay, now I have here exercises. Try to graph these 3 functions, and after you graph them, apply the horizontal line test and just give me the answer. Is this function has inverse? Just write yes or no, this one and this one. Okay, now let's go to a more important part, which is to find the inverse function algebraically. Okay, now as you can see here, the function, okay, let's read the first sentence to understand what I'm going to explain. Now find inverse function. If function passes the horizontal line, means if you apply the horizontal line test and the function just intersect with 1 point, means it has inverse. So we call this function one-to-one function. Okay, so if the function, okay, if the function passes the horizontal line test, so that's mean this function called one-to-one function. Okay, why we call this one-to-one function? Because every x value, or let's say it in different way, every input, okay, it should has one output. Okay, so every input it has one output, so that's why we call this one-to-one. Okay, now let's see how we can find the inverse of the function. Here are the steps that telling you how to find the inverse of the inverse of the function. So first step, okay, check if the function one-to-one by using the horizontal line test. So the first step, okay, apply the horizontal line test. If the function passes the horizontal line test, so you go to the step 2. So what's the step 2 you have to do? Now replace f of x with what? With y. So the function, it will be f of x, so now change f of x and write y. Okay, now after this, step 3, okay, switch between x and y. So the function, it should equal y and x, so now you switch between x and y, so it will be x equal y. Now step 3 is to solve for y. So you have to isolate y and find y. Step 4, switch y with f to the power of -1 x equal this one. So this is the small easy steps. Okay, one more time, let's do it together. So first one, horizontal, okay, horizontal line test. If it's pass, okay, so go to step 2, find the inverse. How you find the inverse? First step, switch f of x and write y. Step 3, change between y and x. So write every x as y and write every y as x. Step 4, okay, solve for y. Means you need to isolate y. Number 5, okay, after you find the y equals something, switch y with what? With f to the power of -1 x. So this is how you can find the inverse of the function. Okay, now look to this example. Determine whether f has inverse function. If it does, find the inverse function and state the any restriction domain. Okay, now so to find the domain, first, before you start, okay, before we're solving everything, okay, just forget this, find now the domain for that function. What is the domain for that function? And as you can see, this is a rational function. Rational function, it's from -infinity to +infinity. It's defined for all real number except any number make my denominator equal to 0. Okay, so you have to take the denominator equal with 0. So now x plus 2 is equal 0. So -2 minus 2. So that means x is equal -2. So now my domain, it will be from -infinity to -2 union from -2 to +infinity. So this one will be the domain of the function. How can you know the range? The range, you take the numerator, okay, same thing, we equal with 0. X minus 1 equal to 0 plus 1 plus 1. So you cancel this. So x equal 1. So now the range will be from -infinity to 1 union from 1 to +infinity. So this one should be the range and here should be the domain. Okay, so this is how we can identify the range and domain, and I already found them, okay, here in the black color, but I just showed you how we can find the domain and the range, okay, again. Okay, now let's continue. So this is here the domain and this here is the range. Okay, now let's keep them beside, okay, because I will tell you later why I found them at the beginning. Now let's start solve the function. So if you remember, the first step, okay, is to graph the function and see if the function pass the horizontal line test. And if you remember, what is the graph of the parent function? If you remember, if we graph it, so it's in a quadrant 1 and in a quadrant 3, right? So the functions look like this one here. Now if I apply the horizontal line test, so the horizontal line test always intersects only with only one point. So that means this function passes the horizontal line test, and because it passes, now let's go to the step 2. Step 2, okay, switch f of x with what? With y. So now I switch f of x and I write what? Y. With the same function. Step 3, if you remember, switch from y and x. So anything y should be x and anything x should be y. So now as you can see, I have here x, I have here x, so I have to replace them with y, and this one is y, so I have to write it as x. So switch between y and x's. Then step 4, solve for y. Solve for y. So now we need to isolate y. So as you can see here, how we can isolate y in this step. Okay, first, when you have a denominator, you need to remove the denominator, okay, to know how you can simplify, or you can take the common factor, or you do whatever. Now, how we can remove the denominator, how we can remove this one, okay, you have always, when you need to remove anything, you have to multiply with the opposite operation. Means if the function is adding, so you are going to minus. If the function is minus, you have to add. If the function is division, so you have to multiply both sides. If the function is multiply, so you have to divide for both sides, right? So this is how you can solve equation. Always you do the opposite operation. So as you can see, y plus 2, here it's a division in the denominator. So to cancel it, you have to multiply both sides here with y plus 2, and the other side y plus 2. So now, after you multiply both sides by y plus 2, you can now cancel this one with this one here. So now it become, okay, y plus 2 times x equal y minus 1. Then after that, you can distribute a property x times y, xy, x times 2 plus 2x equal y minus 1. And this is what you can see in this step here. Okay, so xy plus 2x equal y minus 1. Okay, next step, you need, as you can see, I have y on the right side and I have y on the left side. So our goal is to put all the y's in the same side, okay, and try to move anything next to them to the other one. So as you can see, I will move y to here and I will move 2x to this side here. So I will just switch them, and you know that when you switch the side, you have to change the sign. So now let's keep x and y. Then when I write y, it's positive, so I have to write as negative. 2x is positive, I have to write as negative 2x. Then minus 1. Then this is what you can see in this step here. xy minus y equal negative 2x minus 1. Now as you can see, look to this side. Our goal is to what? To isolate, solve for y. So I have here a common factor. Y is a common factor between this part and this part. So now I took y as a common factor, and you divide every part by y. So this one divided by y, this one is divided by y. So you cancel these two y, so it becomes x. Y divide y is equal 1, because you know that any number divided by itself is equal what? 1. Y divide y, of course, equal 1. Okay? Anything divided by itself is equal 1. Now, next step, okay, I need to isolate y, so I can divide both sides by everything next to the y. Okay, so now what is the next to the y? So the next to the y is x minus 1. So you have to divide both sides by x minus 1. Divide x minus 1. So you cancel this 2. So now y is equal negative 2x minus y over x minus 1. Now as you can see here, y is isolated. Okay, so we just achieved number 4. Now number 5 is switch from y to what? F to the power of negative 1. So this is what you can see here. So I just now change y to, and here this one is my inverse of function. This is the answer. Now if you remember, when I told you if I have a point 5 and 2, what is the inverse? And this one is the function. What is the inverse of this 1.1 and 5 and 2? It's 2 and 5. So what do you think if the domain is from negative infinity to positive infinity? So the domain will be the range, and the range will be the domain. So this is what you can see here. So the domain become now what? Become the range. See? And the domain here become the range. See? And the range become what? The domain. See? Because this one is what I just explained from the beginning. So that's why I found the domain and the range from the beginning, because when you find it at the beginning, so the inverse the domain and the range for the inverse, you just switch between them, and this one will be the answer. Okay, I hope you understand. Now, let's find the inverse for the second function, okay? As you can see, this is a square root function, okay? And the first step, as I told you, you have to graph the function, just sketch it and apply the horizontal line test. So the square root, it's a graph like someone is swimming. It's like this, okay? And now if I apply the horizontal line test, it's just, as you can see, always is with 1 point. So it's past the horizontal line test. Now, let's start with the finding the inverse. So the first step is switch between f of x and write y, and we keep the same function x minus y. Now next step, switch between x and y. So x should be here, y should be here. So we write x equal square root y minus 4. Now step 4 is to solve for y. Okay, so in order to solve for y, I need first to remove the square root. So what's the thing remove the square root? It's square. So when you square this side, you have to square the other side. Anything you do to the side, you have to do to the other one. Now the square, okay, cancel the square root. So it will be x squared equal y minus 4. Now we need to isolate y, so it becomes plus 4 for both sides. So you cancel these out. So y is equal x squared plus 4. Now next step is to switch what? Y with f to the power of negative 1. So it will be f to the power of negative 1x equal x squared plus 4. So this one is the inverse. Okay, now if I ask you what's the domain and the range for this function, you know that, let's find the domain and the range for the original one. You know that domain is always related to h or k, always is related to the h, and range is related to what? To k. Okay, and the domain let's say the domain for the square root function, if you remember, I told you always start from 0 to infinite, right? And the range also starts from 0 to infinite, because what is the h and k here? It's 0 and 0. So now this one should be h, this one should be k. Now if you look to the function, what's h here? It's negative 4. So now the domain will be starting from 4 to positive infinity. Why 4, not negative 4? Because you know h always opposite side. Range related to the k. Do I have k in the function? I don't have k. So it should start from 0 to positive infinity. So this is the domain and the range for my function. Okay. Now the next step to find for the inverse. So the inverse, just do the opposite thing. So the domain will be my range, which is 0 to infinity, and the range will be my domain, which is from 4 to positive infinity. I hope you understand this. Okay, now here we have some questions. Try to solve this question by yourself, and if you need help, please let me know. Now the last part of this lesson is to verifying, okay, the inverse of function. Means you need to know that if you find the inverse, are you 100% this is correct? Means look to this one. If I ask you, are you sure this one here is inverse for this? Or if I tell you, are you sure this one here is inverse for this? How we can know? Okay, by doing verifying. What is the verifying? What we are going to do? We learned in 1.6 the composition function. You remember the composition of function. The composition of function means you insert a function inside a function, right? Now we have the function f of x, okay, and we find what? The inverse function. So the thing that you have to do, you take the inverse and you replace it for the f of x. So it will become f to the power of negative 1. So it should be like this. So this is, you do just the composition of the function. Okay, look to this example here. Now the example is saying, show that f of x is equal 6 over x minus 4 and g of x is equal 6 over x plus 4. So this one is the f of x, this one is the inverse g of x. Now what we have to do, we have to just insert g of x inside f of x, and this is what you can see here. So the first thing, we just insert g of x inside f. So now this one is f of x, so, and this one is g of x, so you have to put this one here. And this is what you can see. Okay, so 6x over 4. 6 over x plus 4. So now how you need to simplify this. So 4 minus 4, okay, and 6 cancel the 6. So now when you have something, example 2 over 3, when you have no denominator, so this part here goes up. So it should be 3 over 2. So this is the answer. So this is the same thing. When we cancel the 6 over the 6, okay, over x, so now x goes up. So this one is the answer. Okay. Now let's apply. Okay, let's apply for g of x. Okay, let's now insert f of x inside g of x. Okay, I didn't mention something. If the answer that you get at the end equal x, so that's mean the inverse is correct. If you get anything else, minus x, if you get 1 over x, if you get minus 1 over x, if you get number, all of these are wrong. Okay, so if anything, any of these answers, okay, show to you, that's mean this g of x is not inverse for f of x. So that's mean this is not inverse, this is wrong. Okay, so you should get x at the end. Now let's replace f of x inside g of x. Okay, means I will take all of that and I replace it in x here. So this is what you can see here. I just replaced f of x inside g of x. Now let's simplify this. And in order to simplify this, as you can see, we can cancel now this 6 with this 6 here, and this term here becomes up. So now the question will become x minus 4 plus 4. This is what you can see. Then we cancel 4 with negative 4, so the final answer is equal x. So did I get x? So that's mean the inverse is correct. Okay? Now if you need one more example, let me do one more example to you, like this one here. Okay, so let me do it. Okay, just very quick. So now we have the function here, f of x, and we have here g of x. Okay, now what should I do? First, let's find f of g of x. So now I have to put everything here instead of this x here. So now let's find the answer. 18 minus 3 multiplied with 6 minus x over 3. Okay, now what we have to do, distributive property, 3 times a6. So now first write 18, negative 3 times 6, negative 18, negative 3 times negative x, so it becomes positive 3x, sorry, positive 3x over 3. Now 18 minus 18, 0, and 3 over 3, so the final answer is what? Is x. So as you can see, this one is inverse for the function. Okay, now the last part here is find the inverse function graphically. So how can I find the inverse graphically? Okay, to find the inverse graphically, okay, what exactly the inverse show me? The inverse, if you remember from the previous lessons, I taught you that the inverse is like a mirror. It's like you are, example, let's say if I have a circle here, it's just a mirror. The mirror, it's like this. Okay, so the mirror should be this one. So this diagonal line, okay, this diagonal line, which is the name of that line is y equal x. The name of that line is y equal x. So now this y equal x is the mirror. Okay, so anything drawn here, it should be reflected over that line on the other side, so it should be here. If I have a graph here, so it should be reflected here. If I have a graph here, it should be reflected here. Okay, so this is how we can graph the function. If you have, example, if you have a function on this side, example, if I have a function like this, so of course this function will be reflected over this one. So as you can see, this one will be the mirror. Okay, now how we can graph this example here given to us? Okay, so always the first step, okay, first step that you have to do is to graph the diagonal line. Always start with the diagonal. The diagonal is always start diagonal things like this, always like this. How you can graph the diagonal thing? If you need to know how to graph it, okay, you know that the linear function mx plus b, right? So always you need to graph y equal x. Now if I ask you what's the slope here, m. What's the slope in this one? It's 1. So 1 over 1. What's part b here? B is 0, and b represent what? Y-intercept, right? So now y-intercept is start from 0, and from 0 go step up, 1 step down, step to the right, sorry. Then you graph a straight line, use your ruler to graph a straight line, connect between these 2 points. Okay, so this is the first step that you have to do. Now, the second step is to pick random point. At least pick 4 points and try to let the points be clear to you. Means, don't pick this point here, because this point you don't know what's the coordinate for this. Don't pick this one here. Don't pick this one here, because you don't know the coordinate. Try to pick point that you know the coordinate. Means, here I know this coordinate, right? So this coordinate here, it should be what? It should be 0 and 1. Okay, I know this coordinate here. What's the coordinate here? Here it's 1 and 2. Okay, pick another point. So you can pick this one here. So this one is -1 and 0. Okay, if the line is intersect with a reflection, okay, pick this point here. You don't have to state the domain for this point, but this point here, it will be shared if the graph is intersect the mirror. So this point will be shared in this graph, and it will be shared in this graph. So you will understand what I mean now. Let's graph the second one. Now, the first coordinate, okay, we know that if I have the coordinate example 1 and 2, and I have 0 and 1, okay, and I have -1 and 0. So I have these 3 coordinates that I picked them. Okay, I wrote them here again. Now, do you remember what's the inverse should be? The inverse should be the opposite. 2 and 1, 1 and 0, -0 and -1. Now, graph these 3 points in the function. Now let's graph them. So the first one is 2 and 1. 2 and 1. So this is the first point. Now 1 and 0. 1 and 0 should be here. 0 and -1. 0 and -1, it should be here. Okay, and this point here on the line, it should also be shared. Okay, so now what you have to do is connect between your line. Okay, so your line will be like this. Okay, it will be go like this, and connect between the line, it should go like this one here. So this is what you can see on the graph. This is how you can find the inverse graphically. I hope you understand this one, and if you have any question, please let me know. Try now to solve this equation. Try to find the inverse for these 2 questions graphically, and if you need any help, please let me know. Okay, I hope you understand everything, and have a good day, and see you inshallah for the chapter 2. See you. Have a good day. Bye bye.